project was inspired by a real learning problem faced by many students. Electrochemistry concepts such as redox reaction, voltaic cell, and electrolytic process are often abstract, difficult to visualize, and heavy with symbolic representation. Because of this, students struggle to connect theory with real-world application. Electrovibe was developed to solve that gap. It is a digital learning module designed with interactive visual, guided notes, and step-by-step problem-solving support. The goal is simple, which is to make electrochemistry more understandable, more engaging, and more accessible for every student.
notation. The half equation in the voltaic cell can be written in the form of cell notation. Okay, so we see this one. This is how we want to write the cell notation. Okay, so remember, the anode is written on the left side first, the negative terminal, okay? Then at the right side, okay, the cathode is written, the positive terminal. Okay, so it's how we write electrode, okay? Then the ionic solution, which is the electrolyte, okay? Electrode is the solid, then electrolyte is the aqueous. So in the cathode, okay, there we write the ionic solution followed by the electrode. Okay, so these two lines here, these two vertical lines means short bridge or the porous spot. Okay, and the direction of electron flows from anode to cathode.
Ta-da! Today we are going to talk about the differences between inert electrodes and active electrodes. Alright, just remember for inert electrodes there are only three types of inert electrodes, okay, which are carbons, graphite and platinum. Other than all these, they all belongs to active. And one more tips, all active electrodes, they are metals. For example, we have equals copper to chloride, okay, for the electrolyte for both, but with different electrodes. So for inert, for example, in this case we use carbon. For active, we use copper. So what are the half equations? Okay, first, before we look for the half equations, always list out all the ions present inside the electrolyte itself. Okay, for example, okay, it's copper, chloride. Since it's equals means there's hydrogens and hydroxide as well. So which one will get the charge based on the position? See, oxide is lower than chloride, therefore hydroxide get the charge. Copper and hydrogen, therefore copper get charge. So anode, hydroxide get the charge. Cathode, copper get the charge. And these are the half equation. For the observation, anode, since oxygen gas is produced, therefore observation will be gas bubbles are formed. Cathode, solid is deposited, okay, because of the formation of copper atoms. Right, next for active, same things, okay, there are copper ions, chloride ions, hydrogen ions and hydroxide ions. So which one get the charge? Since it is active, copper itself get the charge. Okay, not the ions anymore. So very easy, we start with the half equation at cathode first. CO2 positive gas electrons from copper. Then we reverse the equation, becomes the half equation for anode. That's it. Pretty easy, isn't it? Okay, you see anode, solid will decompose to become ions. Therefore, it will become thinner. Okay, now metal itself, it will charge to form ions, and the ions form will goes to cathode to form solid. So therefore, the observation, the anode will be, anode becomes thinner, cathode becomes thicker. That's it. Alright, thanks.